Flipped classroom video for Maths A2 Unit 3, Differentiation of Parametric Functions. So, parametric differentiation. In the same way as with implicit differentiation, we have to introduce or bring back the chain rule and use it, then we do with parametric. So we know from the chain rule that dy by dx is equal to dy by dt times dt by dx. We also know that dt by dx is the same as or equal to 1 over dx by dt. Now remember from when we were looking at the chain rule, and particularly the proof of the chain rule, that these are not always true. These are not always the case, but they are true in all the situations you're going to be dealing with in A-level. Okay, if we put those two together, so the times dt by dx at the end of the top line we replace by 1 over dx by dt, then we end up with dy by dx is equal to dy by dt divided by dx by dt. And this gives us a way of finding dy by dx from parametric equations. So we'll have a look at an example, and this is the curve that we had in the previous video. So, example, find the gradient of the curve given parametrically by x equals 4t squared and y equals 8t. Step 1, find the individual dx by dt and dy by dt. So, for x equals 4t squared, then t squared differentiates to 2t, and then we times by the 4 that we've got, and we have dx by dt equals 8t. For y, we have y equals 8t, and therefore dy by dt is just 8. Step 2, find dy by dx by dividing dy by dt by dx by dt. And so we write that out, and then we pop things in. So dy by dt is 8, and dx by dt is 8t. So that's 8 divided by 8t, which is equal to 1 over t. So we have dy by dx expressed in terms of our parameter, which is nice because we had x defined in terms of our parameter, we have y defined in terms of our parameter, and now we have dy by dx defined in terms of our parameter. Now going on to using this in a practical sort of situation, if we wanted to find the tangent or normal, then to do this we're going to use parametric differentiation that we've just seen, but we're also going to use the old favourite, y minus y1 is mx minus x1. So, using this function again, as an example, we're going to find the tangent and the normal to the curve defined by that parameterization of x equals 4t squared and y equals 8t, and we're going to find the tangent and normal for the curve where t is equal to 4. So t being 4 is a point on the curve, and we're going to find the tangent and normal to it. So step 1, we would need to find dy by dx. Now we've already just done that, so I'm not going to write it out again. I'm just going to state that dy by dx is equal to 1 over t. Step 2, we need values. If we're going to use y minus y1 is mx minus x1, we need to know what the point is in terms of x and y for the parameter value t equals 4. So we need the values of x and y, and we also need what the gradient is at that point. So we need dy by dx for that value of t as well. So, first of all, x is equal to 4t squared, so we can pop our t equals 4 into that equation, which gives us x equals 4 times 4 squared, which is 64. We then put 4 into the y equals 8t, so that's 8 times 4, which is 32. And then we put our value of 4 into dy by dx, so that gives us 1 over t is 1 over 4. Now we want the tangent and the normal, so we may as well, as we're getting all our building blocks, use the fact that the normal is minus 1 over dy by dx, the gradient of the normal rather. So we have the gradient of the normal is equal to minus 1 over 1/4 times top and bottom by 4, and that gives us minus 4. So that's the gradient of our normal. Step 4 is put these values into y minus y1 is mx minus x1 and tidy up. So for the tangent, we get y minus 32 is a quarter of x minus 64. So that's just putting our x, y and dy by dx values in. And we tidy that up by timesing by 4. And then we can put it into some standard form like this, which gives us x minus 4y plus 64 is equal to 0. For the normal, same job, but this time we get y minus 32 is equal to minus 4 times x minus 64, because the gradient, of course, is different for the normal. And when we tidy that up, the right-hand side becomes minus 4x plus 256. Tidy up further, we get 4x plus y minus 288 is equal to 0. And we can see a graph of that. So the red curve is our parametric curve. There should be in red, but never mind. 4t squared, 8t. And then we have our tangent in blue and our normal in green. And you can see those on there as well.